Hi and welcome to the Learn Clang screencast that deals with rock, paper, scissors and every which way. In the last episode we basically have finished the C implementation, so we can now proceed with, possibly a broad topic, which is C++. So I've prepared a little something here. So I've prepared the CPP version of the RPS project. It's still in the same repository, nothing there changed. Also, I've just copied the previous files over and renamed them to tell the compiler that I'm now dealing with C++ code instead of with C code. So all I had to do there is to rename main C to main CPP, and same with the header, the only header we currently have, which is rps.hpp. That's common ways to name C++ code files, by the way. All right, that said, let's try to compile that thing. By the way, something interesting while I'm compiling. The compiler determines by the extension what you want, what you probably want, right? So I can tell you that I didn't change any compiler settings, and I do tell you that the C project was actually compiled by a C++ compiler. It linked in the C++ runtime there, just because Qt Creator is a little bit odd when it comes to that, apparently. So now that's exactly what I want. And that's the reason I can actually compile it just with the same project settings without making any changes here. That's kind of cool, even though it tells us that, and that's the point I'm making here, that the compiler obviously has some internal code that tells it, hey, if the extension is CPP, make it C++ code, right? So extensions are indeed important. All right, let's have a look. So it doesn't compile. It does not compile. Implicit default constructor for RPS item must explicitly initialize the const member ID. I mean, one thing I must say here, it is a gorgeous error message because it's quite descriptive. You know, you could possibly understand what he wants here if you know what an implicit default constructor is. That's where it's used. All right, so let's do it. First of all, why the hell is it now having problems with that? Didn't we say, or didn't we think, that C++ is kind of a superset of C, right? So C is contained within the C++ language. Thus, I should be able to compile C code with the C++ compiler without any issues. Yes, I think that's the case if we actually have C++ code. If we actually have C code. I mean, previously I compiled just fine with the C++ compiler when it was in C mode, but now it's in C++ mode, so it assumes this is C++ code and applies the rules. And the rules changed, man. The rules changed. We're in a different world now. We're in the world of C++. This also means that structs are now exactly the same as classes, with all members being public by default. Whoa, that's a sentence. This also means that classes, and that's kind of the new thing in C++, this also means that classes have all members in private access mode by default. Yeah, so that's the only difference. And this explains why all of a sudden is complaining here, because for him this struct is not a C struct anymore. For him, this struct is now a C++ class that has public members by default, you know? And this is why we now have to comply to some additional rules. Let's reread that. Implicit default constructor for RPS item must explicitly initialize the const member ID. That is true, because constants need initialization when the instance of the class is constructed. And it says default constructor. You know, the default constructor that it wants to have here is the one that is called when actually no additional constructor arguments are passed, or when no additional arguments are passed to the constructor. So the constructor of a class or of a future class instance is called like this, you know. This is calling the constructor of that particular instance, and now I could say, well, I want to initialize this with something that makes no sense, but this would call a constructor, a matching constructor on this type. Type is equivalent to class here. I mean, in Python it's the same thing, right? Type is a class. Class is just a special name to name a type. So let's use it. I use it interchangeably. So I apologize if that confuses you, but I think that's acceptable, at least to me. So this is where the default constructor is implicitly called, and it really tells you that. It tells you just that. And all we have to do is add a constructor here to fix this, to initialize the constants. And I believe that this thing here, you know, it's actually not a constant because the pointer is not constant. It's just any pointer to a character string, right? So this is why it only claims that, oh, this ID needs to be initialized. So let's have a good default constructor. Good default constructor initialize every number to some sensible value. C doesn't force you to do that, which can have performance implication, obviously. Performance implications, because whenever you write or change the value of a variable, you're writing memory, and writing memory costs time. And you know, it's all depending on compiler optimizations, but sometimes it could be that you write memory even though you rewrite that memory later, possibly. I mean, you know, possibly, depending on your use case. And that obviously is less efficient than what C would do, you know. So I'm just saying, C doesn't force you to do anything, but that leaves you wide open to lots of bugs, and C++ has more constraints in that regard. But you can still write efficient and fast code, of course, in C++, but I'm just saying, everything has certain implications. Good, let's get this constructor going, shall we? And by the way, now that we're in C++, we can also just do it like this. I think that is totally valid code. So this type def stuff, it's really C-ish. That's more like the C++ world, you know. Structs in C++ are totally fine, but as I said, it's just classes under the hood with public members. So that looks more like it. This is a default constructor. And it is just a declaration of a default constructor. And I can now, you know, now I'm doing it as I'm supposed to be doing it. Now I will implement this one here in the respective rps.cpp. I think I am able to add the definition to CPP, to rps.cpp. Nice, there we go. So that's how you write it. That's how you define that you would like to implement the default constructor. So what do we see here? Here that's just the class or the type name, colon, that accesses an item in that particular namespace. You know, a class is kind of like a little namespace. A namespace is a feature of C++ that we didn't talk about, but I just tell you that this will be, you know, this is very common to use. Colon access something in a namespace, access a name, a symbol in a namespace, and that's actually the name of the default constructor. And I can tell you that the constructors in C++ are always named after the type that they construct. So RPS item, you know, that's the default constructor. Default constructor, why? Because it does not take any argument. All right. So in this portion, we can put any code here. That's just whatever we want. But in this code, in this area basically, you cannot initialize constants. No, you cannot. Why is that? Because there is, that's kind of special too. There is an area, or let's say a time, before that code is executed that will deal with initializations of member variables. And in case of constants, this initialization portion must be used. And you do it like this, put a colon here. And then you just name the member that you want to use. Do we have ID? I think ID we have, right? And we initialize it like this. So we just set the ID to 0 by default. And yeah, we'll have to make more adjustments to our program in order to make that work. And I can tell you this much. But that's a start. And also what we are going to do is to initialize the name with 0. So that's a pointer, remember? And it's always good to have pointers initialized with 0 just to show that they don't point to anything. So that's kind of a good habit. Last but not least, we shall, oh yeah, this function pointer is something we might want to remove right away, because in, well, maybe we don't remove it right now. We go step by step. Let's just keep it. But we shall initialize it with 0 as well. How is it called? Something like say you lost? Yeah. Say lost, 0. So that's important, that this is the syntax. You can't just assign stuff here. That's not gonna cut it. You just have to initialize this by calling the kind of constructor of that type. It's the same thing. You can call any kind of constructor here in case that is required. Even though in this case, it's plain old data types, that doesn't really call a constructor, but it's just the syntax as it is. Yeah, and I mean, at least I do that because it looks so nice, and you see this in the Qt code as well, in the massive Qt code base. Put a colon here, then the first member that you want to initialize, and then comma separated more and more members. Also something you notice here, that I keep the order of members as they are declared in my class. I keep that the same. Just because some compilers will complain that you messed up the order, which can have performance implications or could possibly lead to missing optimizations. Most compilers will just optimize it the way they want to optimize it. But GCC, for instance, will give you a warning or something. So I just do it kind of in the right order right away, just because I'm used to that. Makes sense. But on Windows, for instance, you wouldn't ever have a complaining compiler, at least if you use Visual Studio with the default settings. Good, that's it. That's already it. That's our implicit default, or that's the default constructor. It's not implicit anymore because now we've defined it ourselves. All right, let us, oh yeah, by the way, one more thing. Let's go here to the declaration. As I said, actually all the members, which are also functions, methods in this case, are public. Every public means everybody can access them. That's the access permissions that are automatically set in structs. I just want to make sure you see that it's not only for member variables, but also for methods. Now using the kind of a new term, previously was always function, and now it's a method, because methods are basically functions that have access to their respective object instance. So that's a method now. Yeah, we will dig in there a bit further soon. But let's have a look at the main.cpp, because I think, yeah, things make no sense anymore, but we will just let the compiler tell us what he doesn't like. Step by step. All right, RPS item. Non-aggregate type const RPS item cannot be initialized with an initializer list. Yeah, so non-aggregate type, what does it mean? Well, to be honest, I mean, I know what aggregation is, right? Aggregation means that one type is a member of another type. And that's just it. And I don't know why it really hates that so much. Or why it would allow it for aggregate types if it tells me that just non-aggregate types are not allowed. Yeah, so I guess what we have to do is to somehow call the constructor on that guy to initialize it. And apparently this struct initialization syntax doesn't really work because it's not a struct anymore. Let's not forget that, it's a class now. And classes, I've never seen a class being initialized like that, to be honest. So I'm not really surprised this doesn't work. Therefore, we shall go back and have a constructor that takes all the information we want and initializes it with with these values. So rp as item. We have a constant char pointer name. We have an integer ID, which is just a constant. We don't really care about constant, non-const here. And the pointer to the say you lost function. That's a bit odd, and we will eventually fix this to make it more C++y, but we will do that just later. So refactor, put the definition here, please. So, oh yeah, let's go back for a moment. Let's go back and forth. What you see here is method overloading. Applause for method overloading. Method overloading is something you can't do in C. Method overloading means that the compiler will pick a method with a matching signature when you call it. So the method can have the same name as an already existing method, but internally, of course, the implementation is different. That's how that goes. That's method overloading. It's really like, or it's just like having multiple methods with the same name, or multiple functions even, that works too with the function, that have different signatures, you know, and that's totally fine. Also, something that is totally fine is, something that is not totally fine is if you only change the return value of a function or method. That doesn't work as method overloading. So the only thing that matters from method overloading and the respective resolution of which method to pick that the compiler does is by setting up the arguments accordingly, you know. That's how that goes. The arguments are the only thing that matters when overloading a method and when the compiler should pick the right one. All right, that said, method overloading, fine, we've just done it. And once again, we go to our initializers here and say name should be name. And ID should be ID. You know, I'm just passing on the arguments here. And say you lost is say you lost. And it's smart enough to realize that this one name is the argument and the other name is the member that I want to initialize. That's awesome. It's also kind of silly code because it really just assigns one to another, but that's something you can't really work around. You have to type it in one way or another. Okay, that's it. Here we can do additional initialization. We could also say you lost and assign 0 again here. We could do that. I mean, it makes no sense, but you know, we can assign non-constants in the portion that is not related to initializers. So I could also, you know, remove this guy here and do it like so. Would be the same thing, but this is potentially more efficient, you know, because the compiler can optimize initializers differently than this kind of code. At least I'm thinking that, you know. I'm just saying, if you want to initialize something, one of your members, put it into the initializers. This code is, or this portion here can really be used if you want to do some special stuff like logging or deal with system resources like open files and such. That's stuff you would have to do here. But that's already it. All right, now that we have a proper constructor that allows us to set every member, we should be able to rewrite this to use that constructor. So what about so? Let's make this RPS items and pass the respective values along. As you can see, that fits nicely. And that's just some grunt work I'm doing now. Okay. Let's just make it so. Make it so. Energize. Let's do this. And it's always good to have a hotkey to join lines, by the way. I couldn't live without it. There's also a hotkey for deleting lines. I couldn't live without that either. So important. Delete line. Oh, that's the one here. It's a bit different to my Sublime Text configuration here. All right. That looks like something that could actually work. You know that? Let's see. Ooh, that actually worked. At least it compiled. That is something. Okay, no warnings, no issues, no nothing. Good enough. Let's see what it does if it runs. Yeah, I kind of screwed up there, sorry. Oh yeah, the run settings. It wants to run in a terminal, so it brings up an X server here on my OS X machine and shows me a little window here that I don't want to see. Close X, thank you. Go back. Forget what you've just seen. Yeah, we could also set it to debug. Why not? And run it again. Oh yeah, and check the arguments here. I think we want rocks and paper, maybe. Oh, haha, P1 invalid. That is true. Like so. Player 2 wins. I'm blind. So as you can see, this program is now, I mean, the changes I made are the minimum changes that are required to get this to work in C++. And we have already created classes, you know. That's something. I like that one. Good. I mean, that was about 25 to 30 minutes. And I think that's a good, smart, tiny, petite episode, because the next one, I would rather not start a new topic now, because the next one is a bit bigger with class inheritance and virtual functions and all this kind of stuff, and I can't cram this into 15 minutes, no way. So I think you have a lot to digest anyway, because all this new stuff, which is just, you know, just the beginning of what classes are in C++, Jesus. I mean, that's something to look up and to digest, so have that time, and I guess I see you tomorrow with the next episode of Rock, Paper, Scissors in C++.